Okay, what we're going to try to do here is just show you how to find the zeros of a rational function and then show you one quirky thing that can happen. Now, what we want to do is set this equal to 0 and to see what happens. Well, that's a fraction. A fraction is 0 when the top is equal to 0. So let's just set the top equal to 0. And we know how to solve this. We should either be able to factor or complete the square or quadratic formula, but in this case, factoring works just fine. Let's see, x minus 1, x plus 3. Nope, it's x plus 1 and x minus 3, I think. Let's just try that. I think that's right. So we get x equals minus 1 and x equals 3. And those are the zeros of the rational function. Now there's one thing we have to be careful for that can happen. And let me just write down a slightly different one to show you the kind of quirky thing that can happen. So I'm going to write down x squared minus 2x minus 3 over x squared minus 1. Now normally I would just set the top equal to 0. But I'm trying to show you what the quirky thing that can happen. Now, if I was to factor the top, I would get x minus 3 and x plus 1. If I factor the bottom, I'm going to get x minus 1 and x plus 1. Now, what's going on here? Right? Normally, when I set the top equal to 0, x equals minus 1 should be a 0. But you can see that if we were allowed to, and when we're solving equations we are, but here we would do that, but we're actually not allowed to change the function, we're only allowed to rewrite it. So if I cross off like this, we can see that x equals minus 1 would not be a 0. Now, what if it's not a 0? If you were to graph this, what you would actually see is that this graph has a hole when x equals minus 1. It's kind of interesting, it's kind of weird, but that's the kind of quirky thing that can happen. So whenever we're finding zeros of a function, as much as possible, set the top equal to 0, find the numbers, and make sure you factor the bottom as well to make sure that this weird thing where a hole appears happens.